In this video, we'll be having a look at the following calculus problem. So we have a function f, and we have to determine where f is discontinuous. And also we have to find where, at the points where f is discontinuous, we have to find where f is continuous from the right, from the left, or neither. And we have this piecewise function f of x over here, so it's equal to x squared if x is less than -1, and x if x is between -1 and 1, and 1 over x if x is greater than or equal to 1. So you can, if you like, you can pause the video and have a go at the problem yourself before having a look at the solution. Okay, so let's have a look at the solution. So firstly, since x squared and x are both polynomial functions, then f of x will be continuous where x is less than -1, and this is where f of x is equal to x squared, and it's also continuous where x is strictly between -1 and 1, and this is because it's where f of x is equal to x. And now, since 1 over x is a hyperbolic function defined whenever x is greater than 1, then f is going to be continuous where x is greater than 1, and this is because this is where f of x is 1 over x. So now we'll have a look at what happens when x equals -1. If you have a look at the limit of f of x as x approaches -1 from the left hand side, you'll get, since when x is less than -1, we have f of x equals x squared. This is the same as the limit of x squared as x approaches -1 from the left hand side, and this is the same as -1 squared, and this is equal to 1. And now if we look at the limit as x approaches -1 from the positive direction, so now since f of x equals x when x is at least -1 and less than 1, this means we'll have the limit of x as x approaches -1 from the right, and this will equal -1. And also, if we have a look at f of -1 itself, since we have x equals -1, this will be the second case. So we have f of -1 equals x, which is equal to -1. So if we combine this information, since the left and right hand side limits are not equal, it means f is not continuous at x equals -1. And however, since the right hand side limit is equal to the value of f at -1, this means f is continuous from the right at x equals -1. But since the value of the left hand side limit is 1, it means it is not continuous from the left. And now we'll have a look at x equals 1. So when x is equal to 1, we can have a look at the left hand side limit, and if we go back to the beginning, as x approaches 1 from the left, we'll be looking at this case over here. So f of 1, or f of x as x approaches 1 from the left, this is going to just be x, and it's going to be the limit of x as x approaches 1 from the left hand side, and this limit will equal 1. And now the right hand side limit of f of x. So in the right hand side, we're going to have a look at this final case here of 1 over x. So this is going to be the limit of 1 over x as x approaches 1 from the right hand side, and this is the same as 1 over 1, which is equal to 1. And now f of 1 itself, so since we have f of x is 1 over x for x at least 1, we will have f of 1 will equal 1 over 1, which is equal to 1. Now we can see the left hand side limit, the right hand side limit, and f of 1 itself are all equal to f of 1, which is 1. So this means the function f is continuous at x equals 1. And finally, if we combine all the information together, we get f is continuous everywhere except x equals minus 1, where it's discontinuous. But although f is discontinuous at x equals minus 1, it turns out to be continuous from the right, but not from the left. Okay, so that concludes the solution to this calculus problem. Hope you enjoyed this video. Thanks for watching, and I'll see you next time.